This meeting is being recorded.
Hello everyone. I am Professor Shiromi Karunaratna and I will be your tutor for the rest of the module. We are going to talk about on the topic of waste management, and under the waste management we are going to look at how the solid waste is managed and also how wastewater systems are designed. So first of all, let us look at the solid waste management. During this first part of the lecture, that is on the solid waste management, we will be trying to see the waste classification and how different solid waste management options are assessed. And also, I am trying to introduce you to the design aspects of solid waste management systems. Before everything, let's look at what is a waste. This is my favorite definition. A resource displaced, that is, the resource is at the wrong place at the wrong time. Also, in generally, we can see solid waste is an unwanted or unnecessary material arising from a human animal activities in solid form. So as long as the waste or the unwanted substance is in the solid form, we are going to call it a waste. So that is the general definition. Depending on different methods, such as based on the origin of the solid waste or based on the material type, there are different classification systems. So let's look at the different classification systems that we can have on solid waste management. If you look at the waste that is based on the origin of generation, right? You can see the waste that is being generated within municipalities, you call it municipal solid waste, right? So within the municipal, there can be different institutions. All the generated waste that is put together within the municipal area is called the municipal solid waste. Then there are waste generated in industrial situations. We call it industrial waste. And then within agricultural setups, maybe farming, maybe paddy cultivation, right? So agricultural waste. Then all the waste that is being generated within as a result of construction activities, we call it construction and demolition waste. Then you can take the institutional waste separately as well. So in our discussion, we are going to pay our main attention to the municipal solid waste management, because solid waste management is a very broad topic, and depending on the origin, the characteristics of the solid waste will vary. So the management strategies will vary too. So within the limited time, we are only going to look at municipal solid waste management. So let's look at the other type of categorization that is based on the type. Now, if you look at the different types of solid waste that you can see around us, there are waste that is biodegradable. That is, that can be readily decomposable, such as food waste, the waste that is generated in your garden, and paper waste, which are biodegradable. Most of this biodegradable waste can be recycled as well. Then there are specifically material that can be recycled, such as glass, bottles, cans of different material like metals, certain plastics can be readily recyclable. And there are inert waste, that is such as construction and demolition waste, and maybe rock debris and so on. And sometimes we may generate composite waste, that is a mix of different uh, types of material that is put together. So sometimes this might be difficult to recycle. And also, there is a category that we have to consider, the hazardous waste. So, which can be generated within the domestic system, or within the institutional system, or maybe uh, most of the time industrial situations, right? Let's try to understand the legal framework within the country, how we are managing our solid waste uh, within the legal framework of the system. Generally, in Sri Lanka, solid waste managed by municipal councils under the municipal council ordinance, and also uh, urban councils under the urban council ordinance, and Pradeshya Sabha. There are different tiers or layers in which this management is being done centrally. This needs, of course, a lot of resources, such as financial resources as well as human resources. And if you look at the waste, how it is being generated, depending on the population, um, generally you will see, in according to the municipal council, urban council, or Pradeshya Sabha, the tons generated per day will vary depending on the population. Not only population, the way the population will uh, behave, or maybe the way of life, how they live, right? You can see in municipal councils, the per capita or maybe the per day generation is larger when you compare to Pradeshya Sabha, right? So depending on the life pattern, or maybe the way they live, the waste generation tend to vary. This is the general composition of municipal solid waste in Sri Lanka. You can see most of our waste being generated within a domestic environment is generated from the kitchen. So most of the time, kitchen waste can be considered biodegradable. Right? You can see almost 75% is generated from kitchen waste. So this is somewhere you can think whether we are actually spending our finances, our human resources for a worthy cause. Now, if you can manage this problem at the domestic scale to a certain extent, wherever possible, the government do not have to spend this much of money and resources to solve this problem. This is for you to think, right? So anyway, we will continue. And you can see the other types of waste, that is garden waste, paper and cardboard, plastic, different types of textile, rubber, metal, glass are in smaller quantities when you compare to the kitchen waste. Let's look at what have we created. What is the problem of the solid waste that we have to manage? So this is some per capita waste generation within different the local area or local authority level. Within Columbia Municipal Council, the per capita, that is the per person waste generated kilograms per day is around, this is the average, but this can vary uh, depending on the way you live, the way you consume, around 0.8. And you can see when it comes to Pradeshi Sabhas, the waste generation is going to be quite low. So this is the amount of waste generated considering different population, right? You can see it can vary between 1 kilogram to even 3 kilogram per capita per day, right? So all depend on the way we lead our lives. So if you look at the Western province waste generation, you can see out of the collected waste by the different collection authorities, Western province generates most of the waste when you compare to other provinces. And with time, it is anticipated the waste generation will increase with the increase of GDP and maybe the spending capacity of the people. The amount of waste that is being generated is going to be increased too. So there are different elements that you have to consider uh, in the with respect to solid waste management. So what have we done? So this is the gravity of the problem if we do not manage the solid waste properly. So this is what the municipalities has done, unmanaged waste, right? And in this area you can see uh, the daily discharge has been estimated as 1 to 1.5 kilograms per day in urban areas, and unmanaged waste that is being dumped will create almost permanent problems in your environment. So what happens if you keep on dumping your waste in the environment? So it will create spontaneous fires sometimes, sometimes intentional burning will release a lot of unwanted gases into the environment. At the same time, it will create leachate, that is the liquid part of the waste, solid waste will get separated over the time uh, in the dumps and will release into the soil or nearby waterways, right? So solid waste will pollute not only atmosphere by uncontrolled burning, but also will create a problem in the groundwater table or maybe nearby water resources, water courses, and also soil pollution. So these are some of the examples. The photographs were taken by myself near the Karadiana waste dump, right? It is a huge waste dump extending around 25 kilometers, square kilometers. And as a result of decomposition of waste, especially the kitchen waste, which contains almost 80% of moisture, right? This moisture will slowly start leaching out over the time and then go and get mixed with the nearby waterways. This is near Volgoda Lake, right? This is one example from Philippines. Now we have first-hand experience in Sri Lanka as well. The waste mountains being landslides, right? So landslides can occur in waste mountains too. We have had the experience of Blue Mandel, right? And the other issue is the most of the waste that we dump without sorting, and we know the composition of waste, there is a considerable amount that is being not being decomposed readily. So this can persist long years. Now this is one example from Tokyo Bay Area. The photograph is taken, but the situation in the most of the open dams in Sri Lanka is the same, right? So this is even after 40 years of open dumping, you can see the plastics. In our case, we have used lots and lots of silly bags. They will remain even after 40, 50 years, even sometimes 100 years, right? We are creating a persistent problem if we do not manage solid waste. So that is why we have to consciously take a decision to manage solid waste, but there are different management strategies that you can adopt. But using suitable management strategies, we have to manage our solid waste. Let's look at the waste management overview. So in Sri Lanka, we can't be happy with the solid waste management practices we have in our different government uh, agencies, maybe at different urban council levels, so municipal council levels, Pradeshi Sabha levels. So, but there are some successful stories, but most of the time we have created a problem and we are still creating a problem. We have not managed to tackle the solid waste that is being generated by the community in a more effective and sustainable manner. Right? So some Pradeshi Sabhas, some municipal councils are trying to uh, solve the problem in certain manners, but still you can see this can be a common sight in many parts of the country. And this is not to be very happy, right? These are the historical dump sites you can see all over the country, right? We have starting from Colombo, Sedavatta, Madambiti area, right? Kolonnawa, and not only around Colombo, but you can see in different other parts of the country, we have created this problem as well, right? So there are ways that we have tried to create, try to convert these open dumps into useful lands, but once you have polluted a land, as we saw, it will take maybe over 100 years to completely decompose and make these solid waste part of the environment. Still, you will create persistent problems. Maybe on the surface, you can create playing fields or playgrounds or some other purpose. You can make use of this land for some other purpose, but still that is maybe on the surface only, but the beneath is still having the same problem. So you might use this open dump site to certain applications, certain users, but it will restrict most of the good use of this land. Okay, so these are some examples, the successful stories of solid waste being managed. As we know, the decomposable part can be converted into compost, right? Uh, there are very good facilities, very good stories that you can hear, right, from different Pradeshi Sabhas. And these are some of the engineered landfills we have. This is the very first one in Sri Lanka, in Dompe area. We will come back to these different types of solid waste management systems later, that is creating engineered landfills. So this is not an open dump, but we are trying to dump our waste in an area where we have created more safety and separated this waste from the rest of the environment, right? So we will see how later. When you talk about the waste management hierarchy, we always would like to start with waste prevention. So if you do not have waste, that is, if you can prevent waste, that is our highest priority. This is the most favored option. So when you can't prevent totally, then you can try to minimize. So whatever we can't minimize, we try to reuse. Whatever we can't minimize, we can reuse and recycle. And also, uh, if you can't prevent, or if you cannot minimize, if you cannot reuse and recycle, then the next option would be you can recover the energy, because we know most of the material has inherent energy that can be retrieved, or that can be extracted in the form of energy which can be used again, right? So again, this is reusing, but in the form of different form. And whatever the material that you can't undergo these 5 steps should only be disposed. But in our country, what we see is our first priority has been the disposal. That is why we have created such a lot of problems in our environment. Not only environment, when you create problems in your environment, that will create a health hazard for the people in the society as well. Right? So these are some of the management options you can see which is happening in our municipalities, right? Most of the different types of waste will have different will end up in different ways of managing. For example, construction waste that can also be recycled, reuse, right? Such as you can reuse the construction waste back in the construction activities, and sometimes, or most of the time in Sri Lanka, it is being end up in the landfill. But very little has been reused in the road construction and so on, right? But the second option is the widely occurring or widely happening option in Sri Lanka, which is we are wasting for our useful resources in landfills. When you talk about municipal solid waste management practices, right, as a municipality, you have to tackle this problem in different stages. So usually from the point of origination, that is from the household level, you will have to collect the waste, right? So waste collection, after the collection, they will be transported using different mechanisms. And then if you do not recycle and retrieve the useful material, you will have to dispose them, right? So here you will see the landfilling. So landfilling can be the last option, but before that, there are a lot of useful resources that you can retrieve for recycling and reuse, right? If you take a municipality, most of its resources are spent on waste collection because it takes lots of time, lots of human resources, and lots of finances. The collection is associated with machinery for transportation, right? So before we go into and see how the municipal solid waste is being managed and what are the uh, engineering inputs that is being necessary for solid waste management, we will try to see this small video.
Did you know that India consumes 12 million tons of plastic, 11 million tons of paper, and 2 million tons of glass each year? Have you ever wondered what happens when you don't recycle all this waste? Around 6.7 million tons of recyclable waste is dumped in India's unsanitary landfills, leading to severe air pollution and water table contamination. Are you alarmed? Well, you can make a difference today by partnering with Banyan Recycling Solutions. Banyan offers professional recycling services to homes and businesses. Customers can avail convenient, on-demand or recurring door-to-door pickup services. Sign up today for Banyan's Earth Credits program. Based on the weight of your recyclable waste, you can receive cash, coupons, or even mobile minutes. The collected recyclable materials are transported to Banyan's materials recovery facilities and are meticulously sorted using scientific techniques. They're cleaned and processed into high-quality materials like bales of paper and plastic pellets and chips of different colors and sizes. The processed materials are sold to reprocessors and producers who manufacture consumer goods that re-enter the marketplace. Banyan's mission is to create a robust recycling supply chain that meets the needs of local communities. Become a partner in Banyan's sustainability movement. Contribute to the economy by signing up today at banyannation.com.
Okay, so you can see there are very successful stories you can see from around the world, right? As I started, waste is a very useful resource, but you could see as long as it is located at the correct place, it is not going to be a waste, right? So we have to create this environment so that you will collect your waste. It can be, the collection can be by the individuals, or can be by the municipality, so maybe collection authority, and then convert these waste into useful resources that can be readily used in the economy again, right? So we call this circular economy, where you will over and over again use the same material for human use. right? And let's look at the process of solid waste management by a typical municipal council or maybe collection authority. So, as I said, the solid waste, especially the municipal solid waste that we are in the consideration, 75% is generated in your kitchen environment. So out of this, majority is decomposable waste, that is being uh, broken down into maybe inert material, of course, with time, but organic substances. So the organic substances can perish or maybe decompose at a faster rate. So when you talk about uh, the collection should happen quite frequently so that the garbage is collected before it is perished, right? So usually we have to consider the fly breeding cycle for collection. So fly breeding cycle is usually the waste, if you keep it outside for certain time, will start, you will see uh, it will generate bad odor. That is because of the microorganisms that has started working on your waste, decomposing. Right. So when you are collecting, usually you will consider this fly breathing cycle in your certain specific environment. Right. So usually in Sri Lanka we have a hot climate or warm weather, and this fly breaking cycle is shorter than in cold climate. Right? So it is typically less than 7 days. So there are different methods of solid waste collection. So I am sharing from the reference I am using. I will show you the reference at the end, right? Um, so there are different collection methods depending on your uh, municipal council, Pradesh Sabha, or whatever, right? The collection authority. Sometimes you will see door-to-door collection. Sometimes you will be seeing the collection will happen in uh, a certain area will have a certain location where you can go and keep your garbage. So for a group of houses, you can have one collection point, right? So depending on your collection method, your collection uh, transportation vehicles will also vary, right? So we have to consider what kind of collection method is being adapted for the collection of your waste. Uh, Now, waste collection needs lots and lots of resources, as I indicated. Um, when you are collecting waste, you need to know how long it will be, like you will take for your collection uh, in your certain area, right? So you will have to do time studies to understand the behavior of collection pattern in a certain area. Uh, Now, this will be useful to determine the amount of human resource that you will have to allocate and the amount of time you spend, that is the area that you can serve during a certain day, and how you can allocate your equipment, vehicles, and so on. So doing a time study for a selected area is very important for you to design a suitable solid waste collection plan, right? So I am going to give you certain information in these slides, right? I will expect you to have a look at these slides when you come for the discussion class, right? So please try to read them. I have put some extra information, so those who are interested can also read and try to be ready with the questions. So these are some details of conducting a time study, right? So this is what I have taken as an example is door-to-door collection, right? So these details are necessary for a time study. You can see now if you consider these blue boxes as two houses, right? And the arrow indicates the traveling path of the vehicle. So we will take this as the vehicle, right? So vehicle will travel from house to the next house, and the people who are collecting the waste will have to get down from the vehicle, collect the garbage bin, dump it to the vehicle, return the container, and then get into the vehicle, right? So the time taken to the whole process can be calculated. So like this, you will try to understand how long your collection, the time of collection for your maybe the given area or given uh, municipality. Depending on the way the houses are located, this time will be different, right? So you will get a certain idea how long it will take for you to travel and collect the garbage in a certain area. So these are the details of time studies that are not very important for our discussion, but I have left it to you. So those who are interested can read and have a look, right? So these time studies are purely based on empirical equations. So for the purpose of calculating and estimating the times, you can use these empirical equations. And the other important element in solid waste management plan is how you can design or how you can estimate the amount of vehicles that you need to purchase or have for the collection, and amount of human resource, that is the crew size, and what is the amount of money that you have to spend on these human resources, right? Labor resources, and also the capital cost, that is to purchase the relevant vehicles and so on, right? All these can be calculated, and you can see the calculation can be done, mostly done on empirical equations, right? So I am trying to leave the details of these equations, but the scope of this lecture will not give us enough time to go into details of these calculations and estimations, but nevertheless I have kept it here so that in case you need it at a later stage, or maybe those who are interested can have a look, right? So this is empirical equation that you can use to estimate the amount of solid waste that can be carried using a truck, right? So this is uh, the VT, that is this left hand side, will give you the volume of solid waste carried per trip by a truck, right? So when you say truck, depending on the the type of truck, the amount of solid waste that you can carry will vary. Now, for example, if you see most of the time in our Pradesh Sabhas, or maybe municipal councils, they use tractors, right? So tractors will have a certain capacity when you compare to the dump trucks, where the dump trucks can be uh, compact the waste, whereas the trucks cannot, right? So dump trucks, the density of waste is more when you compare to the open trucks, right? So you can see different terms here to convert your solid waste into a more dense waste. Let me connect my laptop to the power source. Right. So don't worry about these equations a lot, but the empirical equations are available to estimate our solid waste uh, and use that in the design calculations. So there are different densities of waste depending on the component of waste, right? You can see uh, in Sri Lanka, we don't have much information with respect to these detailed studies, but you can see from different countries, the references are there. And also you can estimate the amount of time that your collection vehicles will take to travel certain distances, right? So this kind of charts can be generated between the total haul distance and the average speed of different types of vehicles, right? So this is one such graph, hauling speed graph I have taken from a reference, right? So this is for your information and to understand the solid waste management plans are really can be really designed using different estimations, right? Uh, and to estimate the amount of time taken to collect waste from a certain area, maybe a certain locality, you can also estimate the how many households can be catered maybe within one trip of a certain vehicle, right? Depending on the vehicle capacity, depending on the time of collection, you can estimate to collect the waste from, let's say, uh, 1 kilometer area in your municipal council, how long it will take, right? So this is important for you to allocate resources such as human resources, such as vehicles to collect the waste from a certain locality. So this is important to make sure the frequent and regular collection from your community, right? So you can see most of the resource has gone into the collection, right? It's a very expensive business for the government, and of course, you know, in Sri Lanka, it's taxpayers' money, and ultimately we will have to pay for our uh, the waste that we create, right? So I have given one example how we can estimate the, the the collection times and the vehicle capacity for collection of garbage, right? So please have a look at this example by yourself, and in the discussion class, depending on your questions, we will go into the discussion, right? So we will try to see if you are interested, you can we can discuss how we can uh, estimate these the disposal, uh, collection, and disposal plans. So I will go into the the next section, right? So this is the example calculation I have put here. Right. So you can see estimation of labor cost also can be done based on empirical equations, right? So you will have to know how much the labor cost, that is hourly wages are for the crew, right? So provided you know the details, you can also estimate how much cost is associated with the labor that is being used in collection. So one example is given here as well, right? And now, when we want to collect the waste from a certain locality, uh, usually the trucks will travel along the roads, right? So you will have to create the minimum distance path to collect the maximum amount of waste during a visit, right? So this process is called the truck routing. That is, you will identify the shortest route that you have to travel to collect the maximum amount of solid waste, right? So depending on the road network you have, you can estimate the path your truck will have to take, right? So this process is called the truck routing method. So depending on uh, the type of collection, right, and the working conditions of the crew, this routing system can be different. That is, you will identify uh, like this, what kind of travel path. Now, if you start from your yard, that is the vehicle yard, what is the route that you can take and collect the amount of waste that is necessary to fill the truck within a certain trip, right? So I am showing these details not to do detailed analysis using these methods, but for you to understand these systems are also there, and this is how usually the management plans will be designed. So once the waste is collected, if the waste is collected unsorted, then the next step would be sorting, right? This is also a time and resource consuming step of solid waste management. But in the process, you can separate and retrieve useful resources which can be recycled, right? Which can be reused, and of course, the rest can be converted into useful, maybe energy by incinerating, and the rest can be sent into the landfills, right? So the landfilling should be the last option in a good waste management plan, right? So this amount, or this landfilling volume is going to be very minimum if you follow this good practice of waste separation and reusing as resources. So we will try to look at very briefly different solid waste management practices, right? So the most easiest or most convenient type of solid waste management is associated with the decomposable part of your waste, that is the waste being generated from kitchen environments, right? that is very suitable for composting. So there is a science and engineering in composting as well. So we will try to see only the key elements of composting, right? And as we know, the process of composting is the transformation process of organic material into biologically inert or maybe biologically rich substances that can be reused in our agricultural practices, right? So the decomposing process is happening as a result of different microorganisms and different organisms, right? So the invertebrates such as insects, earthworms are working to convert this decomposable material into biologically rich substances which we call compost. And also microorganisms are working really hard to convert in this process, right? So now if we want to engineer the composting process which is happening anyway in the environment, we are trying to create favorable conditions for these machines, rather the living machines, to convert the compostable solid waste into compost, right? So we will see how it can be done. So we know if you do not manage your waste, the decomposable part of your waste, and dump it somewhere in a dump site, right? It will create problems in around our environment, like because it can emit different gases, right? And it can release leachate. So we need to convert the waste into compost in a certain scientific manner, right? So composting is going to help us to manage our waste so that you do not create your environmental problem. And the composting process is going to give you very useful resources that can be used in the agricultural activities, right? So, but we have to understand uh, the input quality of your waste is very important for your quality compost, right? That is, you have to make sure you do not mix your waste with hazardous materials, such as maybe in your domestic environment. Sometimes we tend to mix our waste together, right? Maybe you put batteries, you put different other chemicals that are being used in the domestic environment. So if you mix hazardous material with your compostable part of your solid waste, then the compost that you are going to make out of those is going to be contaminated with those hazardous material. So the contaminated waste generates contaminated compost, but those are not suitable to be used in agricultural activities, right? So always you have to make sure the waste is properly sorted before you can go for composting. And if you want to design a suitable or proper composting facility, you have to pay your attention to the composition of your waste, right? So we have to make sure the waste that you are trying to use for making compost will have certain attributes, right? So the these are the considerations that you have to pay your attention, right? Here you will see we have to make sure a certain carbon to nitrogen ratio in your waste so that it can be readily converted into compost. So generally, the C to N ratio or the carbon to nitrogen ratio should be maintained around 20 to 1 or 35 to 1 range, right? So that is carbon to nitrogen, right? Because now you know this decomposing process is done by the living organisms, right? So for their growth and reproduction, we have to provide a carbon source and an energy source, right? So therefore, carbon to nitrogen ratio is very important for a effective composting process. And of course, we need to provide a certain amount of air, that is the oxygen has to be provided, because the composting process is being done most of the time by aerobic microorganisms which needs oxygen, right? And then it has to have a certain correct moisture content. So usually it should not be too much, but you have to maintain it around 60%. So if you want to have a effective composting process, you have to make sure these requirements are fulfilled. And also you have to maintain a certain pH, that is around 7, right, to be the optimal conditions, but it can be varied between 6 to 9, right? And temperature, very important. A certain temperature is desirable to for this decomposition process of the waste or the decomposable material, because again, because of the living machines that is working in this process, right? So around 50 to 55 would be the maximum or the desirable temperature in the initial days. And you know, the process will have different temperature ranges. So initially a lower temperature around 50 to 55, and then the last days you will have to have a little bit higher temperature in the in the process, right? And also, since we are going to use this material in agricultural activities, we don't want to have pathogens with your compost, right? The higher temperatures will eliminate these pathogens from your compost, right? So in this natural process, you will see a variation of temperature with time, right? So it will usually taken care of in the process. But if we want to facilitate composting using engineered systems, then you will have to support all these parameters so that the composting will happen at a rapid stage and a more effective manner, so that these the parameters are optimized, right? And during the composting process, you will see mixing and turning is necessary so that you can provide favorable conditions by providing sufficient air, sufficient moisture content, and controlling the temperature, right? Right. So when we are composting, you have to make a balance between the greens and browns, we say, to control your carbon to nitrogen ratio, right? So when you have uh, different elements in your waste, right? Such as if you want to use your kitchen waste, then you will have to consciously mix that with the brown waste as well to make this C to N ratio appropriate for composting conditions, right? Okay, so let's look at what are the different composting methods that has been used, that can be used when you are generating a compost in commercial scales, right? So this is large scale composting. You can specifically see 5 different types of composting methods uh, depending on the available resources, right? Depending on the space available, and you can select different method of composting. The mostly the most municipal councils in Sri Lanka, you could see the windrow method is popular method, right? That is we are building thoroughly mixed waste material in the kind of uh, uh, small heaps, right? Small long heaps, so that you can provide sufficient air, and also it will facilitate time to time turning for proper maintenance of the conditions that we mentioned earlier. Then we can have passively aerated windrows, and we can have actively aerated windrows, right? And all these different types will facilitate different conditions so that you can optimize the conditions necessary. So this will facilitate more rapid decomposition, and the composting process will be accelerated. So let's try to understand how the decomposition of the compost, or maybe the composting process, will happen using the microorganisms. So usually in this process, the living organisms will break down the organic matter into uh, the primary materials that can be readily used for as a fertilizer, right? So depending on the type of living organisms, right, and the amount of or the characteristics of the waste, we can see 3 different distinct phases in composting, right? The first phase can be identified as the, depending on the temperature, we identify these phases. We call this mesophilic stage, where your the temperature of your waste increases to kind of moderate levels, right? And this temperature will be there for certain time period, right? So until the reactions will occur, reactions in the sense the microorganisms will start working on your waste, converting your organic waste into decomposable material. And then after some time, the temperature will change into thermophilic state, where you will see a relatively higher temperature phase, right? This will again will last a certain days, days to a few weeks, right? And then the cooling down of this process. So naturally, the composting process will undergo the three phases of temperature. So therefore, when you are providing or facilitating the process by providing different hold on, sorry.
This meeting is being recorded.
Okay, let's continue. So this is the typical temperature variation you can observe during the composting process, right? Over time, there is temperature increase gradually, and then you will have a maintenance of higher temperature, then decreasing of compost. So compost total process has to be like you have to have the total period for the composting. You have to allow the total period for the composting process to be completed, right? Now in this slide, I am trying to show you how different communities of microorganisms predominant during different varying phases of composting, right? Now, as we indicated earlier, uh, at moderate temperatures, there are different types of microorganisms that favor different temperature conditions. We call that mesophilic microorganisms. They love moderate temperatures, and they are the type of organisms that will be dominant within that phase of the breakdown of the compost, right? The degradable material will be converted into compost by this mesophilic microorganisms. Then the temperature goes higher and higher in the maybe pile of compost, right? The type of microorganisms shift to a different variety, right? The microorganisms which can live there in a higher temperature. We call it to mesophilic microorganisms, right? So they can survive in higher temperatures and they will further break down the compost into, the waste into compost, right? They further break down the organic material. And then the temperature will go further higher and we call the thermophilic phase. This is the accelerated breakdown of basically proteins, fats and carbohydrate. And in this environment, you will have higher temperature and the microorganisms which can survive the higher temperatures, right? So this is towards the last part of composting process. So you can see during this process, the type of organisms present in the waste pile, the compost pile will change over the time. So as we indicated, maintaining the appropriate carbon to nitrogen ratio in your the solid waste that is being used for composting is very important because it will allow the correct conditions for the microbial population. And this will make sure the microorganisms will have the correct food source and correct energy source to function in the environment, in the given environment, at the optimum capacity, right? So as we said, the ratio would be ideal between 25 to 35, right? So what will happen if you do not provide sufficient C/N ratio? Now, if the C/N ratio is low, right, that means your carbon is less, right, and nitrogen is more. That is, nitrogen will be supplied in excess, and it will be lost as ammonia gas. So this will lead to stinking or maybe giving undesirable odors in your compost, like in the composting process. So if you have a higher ratio, that is, you have more carbon and less nitrogen, right? There will be not sufficient nitrogen for the optimal growth of the microbial population, because the microbial population need to multiply, grow in the process, right? So that is how you can do a better job to maintain the correct population size. So composting, the process will slow down because you don't have enough microbial population, and your composting process will not be completed on time as you expected, right? So maintaining the correct dose of C/N ratio is important for your composting process to happen at the optimal state. And also you need to provide sufficient oxygen, right? And oxygen is necessary for the oxidizing process. The microorganisms oxidize carbon as using energy source, right? And as a result, oxygen is used to produce carbon dioxide, right? So if you do not provide sufficient oxygen, the process will not happen, because in the lack of oxygen, the process will be converted into anaerobic process, where in the anaerobic bacteria will live and dominate, and it will start emitting methane and other undesirable gases which will give bad odors, right? So this is where the land, the solid waste will converted into a dump, right? Now you know this is what is happening in the solid waste dumps, because the huge piles of waste being dumped, and the temperature increases within the waste pile, and because we do not have sufficient oxygen, because waste dumps are not mixed, right? So anaerobic conditions are being generated, and as a result, this the gases such as methane and hydrogen sulfide will be generated, right? So that will pollute the environment. So because of that, you have to make sure in the composting process you provide sufficient oxygen. And also, since we are working with living organisms, we have to make sure that the micronutrients are provided in correct quantities. So sometimes if the nutrients are not sufficient, you will have to provide some amount of nutrient to make the balance, and also the correct pH, right? Since the microorganisms are favoring certain pH ranges, optimally 5.5 to 8.5, you have to make sure your waste is at the correct pH, right? And depending on the stage of your composting process, right? Now we saw that this decomposition process will take a certain time and it will undergo certain temperature changes, right? So if you do not have, if your waste do not undergo the full cycle of this decomposition phases, the compost can be categorized as immature and mature compost, right? So if the complete cycle is not completed, the compost can be termed as immature compost. So this immature compost is not suitable, or maybe not yet ready to be used as compost in plantations, right? So it might have a higher temperature, it might have living microorganisms that can harm the plantations, right? So you have to wait until the compost will complete the complete cycle of maturity, right? So once the compost is the composting process is completed, we can call it mature or completed compost, which is ready to be used in the desired purpose, right? Otherwise, the compost will have certain problems if you apply that into farming lands. Right. So let's look at the next option of solid waste management. That is how you can create, or what are the attributes of a sanitary landfill, right? So we know the waste that cannot be recovered and reused as a useful resource has to be managed in a certain manner, right? Because if we do not have the technology to extract the material and reuse and recycle, then there should be some option for us to take. So that is the last option as the landfills. So not just dumps, right? Which will again create problems in the environment and in the society. The sanitary landfills are supposed to provide or give minimum impacts into the environment and to the society. Right? So let's see what is a sanitary landfill. So in contrast to the open dumps, sanitary landfills are going to be, it will not create atmospheric pollution, right? And if you compare or see the difference between the dump, solid waste dump, to a sanitary landfill, right? And dump is an uncontrolled dump causing hazardous or maybe different hazards to human and environment. In contrast to a controlled landfill, it is a dump with covering of waste, but still engineered landfill is the best. So it is the form of controlled landfill plus engineering measures to limit the impacts, right? So impacts to the environment in the form of gases, in the form of liquid waste, right? So sanitary landfills will provide you the best option of managing the waste that cannot be managed in other words and other ways. So that is the highest, or maybe the safest form of disposal technique for the solid waste, right? So it will make sure that it will not create any problems in the environment as release of gases, and it will not release leachate, so that the groundwater table is uh, polluted. So in a sanitary landfill, we make sure that we separate the waste from the rest of the environment, and also we will monitor the system in the long term so that it will not create any problem at all during over its lifetime, right? So usually a sanitary landfill will be operated over a period of maybe 20 to 30 years. Okay? So during the whole life cycle or maybe lifespan, a good monitoring system will be installed so that you make sure that it will not create any sorts of pollution to the environment, right? So if you compare all these options from dump to sanitary landfills, you can see sanitary landfill is safest, but it is the most uh, costly option. Right. So we have discussed the impacts of dumps, right? And what will happen in a dump? You know, when exposed to rain, it will absorb moisture, right? And in the presence of moisture and the decomposable material, you know, the the composting process will happen when you have organic waste in your solid waste dump, right? So which will emit to the environment, and also which will create leachate, and that can pollute surface water bodies as well as groundwater. So in engineered landfills, you have to take care of the emissions, you have to take care of leachate so that you will avoid surface water pollution, groundwater pollution, and air pollution, right? So in engineered landfills, you will have to provide mechanisms, or sanitary landfills, you will have to provide mechanisms to take care of these problems. So I will skip the landfilling options and go into the sanitary landfills. Now, if you look at the different components of a landfill, right, you can see the waste is covered by different types of material in landfills, but it does not take care of the groundwater contamination, right? But this is relatively cheaper than a engineered or sanitary landfill, right? Now let's look at how these engineered or sanitary landfills look. So those needs huge land areas, right? And lot of engineering activities are associated. So this is one very good example from our own country, where we have created a sanitary landfill in Aruvakkaru area. So this is the site. Earlier it was used to mine calcium carbonate necessary for production of cement, right? So after the calcium carbonate is mined, the area has been uh, abandoned. So this area has been turned into a landfill, right? So it's a engineered activities and it's a huge investment and cost. So let's try to uh, look at some of the other landfills that we have in Sri Lanka. This is the very first landfill, sanitary landfill we created in Dompe area, right? So this is how it will look like once the landfilling operation is completed. So you can convert that into useful land, but still beneath you will have the waste. So let's look at how a sanitary landfill can be created. What are the components, right? So as I indicated earlier, we have to make sure uh, the emissions to the air, emissions to the soil are eliminated so that it will not pollute groundwater, it will not pollute surface water, and it will not pollute the environment, air, atmosphere, right? So to cut off the leachate that is being generated in waste, you have to provide sufficient barriers, right? So you can see different types of barriers should be created, right? So here, usually, at the bottom of this sanitary landfill, now here you can see in the yellow area, this is the waste that are going to be dumped, right? So ideally, the waste here should be the residues left after uh, retrieving all the useful material, right? So material are salvaged before you dump into the sanitary landfill. So the material that you don't know how to manage will go into the landfill, but rest is taken out, right? So that ideally that is the situation. That should be the situation. So what you will have as different components in the landfill. So basically you will have to have a barrier system to prevent the leachate or the liquid part being released into the soil. So you will have a clay layer, we call it a clay line. You know, clay is a material, if you use appropriately, it has a very low permeability. That is, through the clay layer, the transport of moisture or water is very, very slow, right? So the first barrier we create is a clay liner, right? So the thickness can be varied between 1 to maybe 2 meters depending on the quality of the clay, right? The size of the height of your landfill, the field that you are going to make, and so on. So you will have to use appropriate clay or the appropriate type of clay as the clay line. So usually the clay material within a certain vicinity or maybe within the locality of your landfill site is collected for this purpose. Then on top of the clay liner, right, you will have different other types of barriers. You can see here you will see on the top of the clay the geomembrane, which will further reduce the leachate traveling across this geomembrane, right? So these are these membranes will stop the release of liquid from the waste to the soil, right? Then on top of the geomembrane, again you will have a layer called geotextile, right? So all these layers will prevent the liquid being escaped to the soil, right? Leachate being escaped to the soil. Now, when you provide these barriers, at the same time, you have to create a system to collect and discharge the leachate that is being generated within the solid waste dump here, right? So whatever the leachate that is expected to be generated will be collected through a pipe network. So what you have to do is, after the lining system and within this geotextile layer, you are going to place leachate collection pipe system, right? And on top of the geotextile, you will have a packed bed where you will use like aggregates or gravel layer to lay these pipes, right? So this is where you will collect the leachate that is being accumulated in the waste. So at the same time, uh, you will have to provide some mechanism to pump out the collected leachate. So you will see this kind of a sump where the leachate can be collected, and you will have to have a pumping system to take the liquid part out, right? And once you take the leachate out, you can't just release it to the environment. You will have to treat, right? So we will be talking about wastewater treatment. So similar to the wastewater treatment, you will have to treat this contaminated liquid using appropriate means, right? So that is to tackle the liquid part. So how do you tackle the emissions, right? So sometimes, uh, or most of the time, you will see some types of gases being generated within the system, within the waste dump. So you will have to allow, similar to the leachate, these gases to be collected and vented out, right? So the gases like methane will be generated, right? The gases like sulfur dioxide will be generated. So those gases will be collected, and you will see these gases has to be burned out before you release into the environment. Otherwise, you know, methane is a gas which has global warming potential, greenhouse gas. Right? So we should not release it as it is. Therefore, burning will have to be done, right? And then these sanitary landfill systems, as I indicated, are operated for very long years, right? So usually the sanitary landfill is operated over a elongated period of time, and also once the landfill is reached its full capacity, you will have to cover the landfill with a similar membrane system, right? So you will have a geomembrane system, then you will have different types of geotextiles to cover it, and a soil layer, and on top of that you can have a plantation like trees and so on, right? So this is how you will finish landfill site. So this is a very long-term operation, as I indicated. Maybe it will take more than 20, 30 years. So you will have to make sure over the elongated time period, your sanitary landfill will be safe. It will not get damaged due to different reasons. Maybe, over the time, the barrier systems can give away. They can crack. They can maybe uh, break, right? So to make sure that you do not allow any contamination, you can monitor the groundwater table for any pollutants. So you will see around sanitary landfill site, you will have groundwater monitoring wells. So time to time, you will take samples and make sure there is no pollution happening beneath the soil layers, right? So that is the purpose of groundwater monitoring wells. So now you can see this is a huge operation and huge cost to build. So it's not an easy job. We will have to undergo a long process uh, when we are trying to develop a sanitary landfill. The first challenge is to find a suitable land, because now we know this is a long-term process and it needs a large, considerable area. You have to make select the site appropriately, right? And the site usually should be away from human settlement, and so that it will not uh, uh, interfere with day-to-day activities of the society, and also it will provide sufficient surroundings or suitable surroundings, so that in any case the pollution can be prevented with respect to the soil, groundwater, and the atmosphere, right? So you create sanitary landfill mostly away from the human settlement. And also, when you select the site, right, we have to be mindful about the distances of transportation of the solid waste. So, as I indicated, usually it has to be away from the human settlement, but it should be in a distance that it will not be a huge additional cost with respect to transportation, right? So you have to locate the site uh, in a way that uh, you consider the land availability, of course, but of course you have to make sure the hauling distance. The whole distance is the distance that you have to take the solid waste using different transportation modes, right? And uh, at the same time, it will reduce the hauling costs associated. And also you have to pay your attention to the rainfall and wind conditions and hydrologic conditions, that is the surface and groundwater, and also very important geological conditions. Now you can't be locating your sanitary landfills in the areas where they are prone for landslides, right? And also you have to consider the ecological conditions of the area. So they should not be ecologically sensitive areas as well. So you will naturally see, you will have to do environmental impact assessments for the sites that you want to select for sanitary landfills. And also you have to consider the other aspects such as the regulations and the legal requirements and so on. When we consider the facility location, as I indicated, we have to have other associated facilities. You have to provide a leachate treatment plant, that is to treat the liquid part of the waste, and also you have to have a certain mechanism to manage the gas generated, as I indicated, the methane burning process, right? Gas management and treatment system. And also you have to construct access roads uh, like for the transportation of the machinery, vehicles, and also you have to consider the economics of your sanitary landfill. That is area versus the height you can go, like what kind of a height you can go and what is the extent of the land area can be utilized for the waste. And the other considerations such as the administration aspects related to the waste management facility, because this is a long-term operation, you will have to build buildings and associated infrastructure has to be facilitated. In the sanitary landfill or municipal solid waste landfill design, you can have different approaches, right? Now, in some sanitary landfills can be built to isolate the uh, the the waste that has no other means of reusing and recycling. We call this dry tomb, or maybe we don't get any active use of these sanitary landfills, but we try to make the waste in a maybe place it in an enclosed area for a longer time of period, right? So we want to isolate the waste that we don't or we do not have means of reusing and recycling. And on the other hand, if you use this landfill as dump sites for mixed waste, where your salvaging is not complete, you can expect more activity within the sanitary landfill in the form of generation of different types of gases. So we can create them as bioreactors, right? So what you are going to see is active landfill or active sanitary landfill dumps, where you will actively collect the gases that is being generated, and instead of destroying the gases or burning out the gases, you will use the gases for useful purposes, right? Maybe you can extract and refine methane and use it as an energy source. It can be given to houses nearby the sanitary landfill site for cooking purposes, for other purposes, right? So these are called the bioreactors. So these are not inert dumps where you monitor it so that the pollution is prevented, right? So you are going to create, or you are going to take some use out of these landfill sites. So there are different types of forms that you can create this landfill into, right? You can make them above ground, you can make them the ground level, subsurface, or combination of those, or like this, right? So depending on your available land form. Now in the selected area, what kind of a topography is there? Depending on the topography, you can select what type of uh, landfill you can go for. So again, you can see different elements of different shapes of landfills and how you can place the different elements. The liner system, we can say the bottom cover, or the bottom liner system, and the top cover, right? So you can see here your leachate collection system, as well as the gas trapping system has to be installed. Now, since the sanitary landfills are huge structures that will be there for over a long period of time, so we are going to have a certain impacts in your environment, right? Now, we are trying to reduce the impact of solid waste that is being created, but at the same time, because of this facility, it is inevitable that we create a certain impact in the environment. So therefore, this can be considered as a project which needs environmental impact assessment. And also, it will has to go through the official path of obtaining permission, doing a preliminary design and preparation of design documents, right? Because it is associated with a huge construction activity as well. So these are some of the considerations in the design process of the sanitary landfill, right? So you will have to plan your landfill properly, and you have to think of the possibilities of extensions if needed. So this will be the case in most of the landfills, sanitary landfills, and how you are going to finish off the landfill. That is the top cover or the final cap, and how you are going to operate and maintain the sanitary landfill for the next maybe 100, 200 years to come. So that's a huge challenge, right? So that is the end of the, the, the second option of solid waste management, that is the landfill. And I have added some questions with respect to the solid waste collection systems and the management systems that we talked earlier, right? And I have put some answers also. So you can go through these questions, right? Specifically, these questions are related to the calculation-based questions, right? And in the discussion class, we can talk about the other aspects of management, such as composting and landfilling, right? So please go through uh, the slides leisurely, and please be ready with the questions. So let's wind up this session now. Thank you very much for your attention.